Hello and welcome back to my channel. Today we are going to talk about stacks, and we're not talking stacks of cash. We're talking stacks of memory, and yes, I'm going to bring plates into the picture again. Plates, because stacks are last in, first out. So these are data structure, and I spoke a little bit about them on the first data structure video that I've ever done. It's in the playlist for data structures, and basically you pop off and push on. So the entry point and exit point are both the same. They have to be at the top of the stack. If you're new to the channel, this is Java with Ali, and I am Ali. So thank you to all the people who have subscribed so far. Welcome more who are subscribing, and there's a new video out usually every Sunday. And today we're going to talk about stacks. Next week will be queues. So it's going to be a short video today. Hopefully it's building on the previous video. So check out linked lists if you're unsure about it, because we use some of the code from that as well. So stack. So a stack is a constrained list. There's new nodes, or we call them nodes. New nodes can be added to and removed from the stack. Only at the top, and you will see this in our code today. So it might be easier to visualize it when you see it. So a stack is last in, first out, as I said, LIFO. So the link member in the bottom node is set to null to indicate the bottom of the stack, and we spoke about that as well last week with linked lists and other data structures. Usually the bottom one is going to be set to null. So the bottom of the stack, to indicate the bottom of the stack, is set to null. So a stack is not required to be implemented as a linked list. It can also be implemented as an array or an array list, for example. And today we're going to have a look at this code. So let's dive in. So we're still in the package structures, I called it, with the lowercase s. We have a no such element exception. Part of the java.util package that I've imported. The name of the class is stack test with a capital S as usual. Public static void main. This is our entry point, and we create stack of type integer. So if I go to stack then, because we're going to use this code first. And here it's pretty similar to the linked list stuff. So for example, when we're using things like push, pop is empty, and print, it's the same methods that we're using in the linked list. So we have 4 methods in this. We also have our constructor, and we use collections. If you're unsure, check out that video too. So for example, when a program calls a method, the called method must know how to return to its caller, so that the return address of the calling method is pushed onto the program execution stack. And I spoke about it in the very first data structures video. And if a series of method calls are being called, so I'm going to go back to my plates. So here is one method. It's got sent over. So in the previous video, I spoke a little bit about methods being kind of like employees in a department where your boss is sending off employees to do different things. They don't actually need to know how or what they're doing, but as long as they go off and do the task, and that's your method. Your method is your task to be done. So the top of the stack is now gone. The next one is now gone as well. And the return address then is going to be pulling them back into the stack until it's closed, and the program execution stack is finished. Sorry about the noise, it's plates. So stacks support recursive method calls in the same manner that they do support conventional non-recursive method calls. So the program execution stack also contains memory for local variables, which we spoke about in that video too, on each invocation of the method during a program's execution. So every method, when we have a local variable like this one here, like push, we have eObject that is only going to stay alive within this method but we also call the stack list insert at front method as well. So that's multiple methods called within a method. That can also happen. Compilers use stack to evaluate the arithmetic expressions and generate machine language code to process code. So stacks are really important. So if we look here, we take advantage of the list, which we spoke about last week. So here I've commented out this because it will just return gobbledygook, because we don't we're not using last node stuff anyway. So we'll come to that in a second. So here we have our list.java. If you're unsure, check out the previous video. Also, it's on my GitHub. You have access to the code freely available there as well. So we use composition then by including a reference to a list, and within that then we include the list object as a private instance variable, and so then stack structures are implemented to store the references to objects and any type to encourage further reusability, which we spoke about already. So then we have class stack here, which is lovely. Stack, which takes in E, and it has our push, our pop, is empty, and print. So our four methods, which are pretty much the same as insert at front, remove from front, is empty, and print in list. So insert at front, we obviously can't use insert at back because that's not available within a stack structure, data structure, or remove from back is also not available because we can only use from the top, add to the top and remove from the top as well, because it's a stack, last in first out. So we implement each stack E method as a call to list E method. This is called delegation. So if we want some words that we use in regular language that we can use, so we delegate. So we delegate the work to the appropriate method. So stack E here delegates to list. It's private, and inserts the insert at front. It uses the insert at front and remove from front, which is here and here. So then we have our stack test when we've created that, and we use our push method to push on. So we're pushing on and popping off, and that applies to nearly every programming language. So if you have other programming languages, I'm currently using a lot of TypeScript in work at the moment, and there's an actual like push methods that's used within, anyway, it's called push. So then it creates the stack integer object called stack, which we have here, uses the pushes and then auto boxes it. Remember, we auto box because it's not using a primitive type, we're using a reference type. Note the capital I for reference type and also the full length of the word integer. Otherwise it would just be int with the lowercase I and just the 3 letters, and it's primitive type. So in this case the program then displays the exceptions stack trace as well. So if I run here, because I'm after, hold on, let me scroll down and you can see. So while this, we're using a while loop this time, continue loop is true, so we set it to true first. Remember our default for primitive types as well, and the default usually for Boolean is false. So you can set, you have to set it to true first. So while Boolean, while continue loop is true, then try popping it off. So you set, we're calling our pop and assigning it to remove item, and then we show it on the screen, and we catch the exception. As we said, the shortened version for exception can be E or EX as well. Oh, we can use that as well, and it prints to the stack trace. So we're going to see the error on the screen. So when I run it, you can visualize our last in first out, because you can see from the top of the screen once it appears here. So here's our push. Oh, hang on a second. Here's our push. Here is -3, so that's the top of the stack. Then we push again onto the top of the stack, -2, so it's going to appear here as opposed to at the bottom. Again, -1 is going to appear at the top, 0, 1, 2, 3, and it's going to be removed this way as well. So 3 is going to go first, be removed first, I mean, 3, 2, 1, etc., all the way to -3, and it just prints it out along the way. And it prints out our stack trace, which shows the stack is empty. And that is it for today. And it shows you as well that it's what lines are called. List.java, it's called list, it's called stack line 19. Alright, line 19. So it gets to here, and stack for line 29, which is here. So that is it for today. Thank you so much for watching. If you like the videos, please like, share and subscribe so I know to make more. And the next video is going to be queues. So I look forward to that. Okay, thank you, stay safe, and thank you for watching.